Hello and welcome to Thoughts on Rice, a podcast hosted by the University of California Cooperative Extension Rice Advisors. I'm one of your hosts, Sarah Marcianish, and I'm a rice farm advisor for Colusa and Yolo counties.
I'm Whitney Brim DeForest. I'm the Cooperative Extension Rice Advisor for Sutter, Yuba, Placer, and Sacramento counties.
My name is Luis Espino. I'm the Rice Farming Systems Advisor for Butte and Glenn counties.
I'm Michelle Leinfelder-Miles. I'm a farm advisor in the Delta region. I work on all sorts of field crops, grains and forages, but one of those is rice. And the counties that I cover are San Joaquin, Sacramento, Yolo, Solano, and Contra Costa counties.
Together, the UCCE Farm Advisors seek to provide relevant, topical, research-backed information relating to California rice production. Today I have the privilege of sitting down with Jens Beets, who's a research ecologist with the USDA Invasive Species and Pollinator Health Unit. The mission of this unit is to develop and transfer integrated, biologically based approaches for the management of invasive species and improvement of pollinator health. I've asked Jens to be here today to talk about algae and cyanobacteria management, how it relates to our California rice production, and management practices that may help treat this problem. Hi, Jens. Thanks for taking the time to be here today. Can you start off by telling me a little bit about your background and your education?
Yeah, thanks for having me here today on this dreary day. I guess we're finally getting rain, which is much needed.
Man, you should have been here last week. It just poured and poured.
Yeah. So about me, I've kind of been all over the place. I grew up in Hawaii. And then I went on to do my bachelor's up in Washington at a little school in Tacoma, just south of Seattle. And as pretty much any kid finishing college, I was freaking out looking for a summer job after graduation, and luckily heard about a researcher in Florida who was looking for a summer hire to work on invasive plants, specifically invasive aquatic plants, so all the things in lakes and rivers, which Florida has plenty of lakes. And that very quickly, and this was Dr. Mike Netherland. He was a Army Corps of Engineers researcher stationed at the University of Florida in Gainesville. And that very quickly transitioned into a master's. I was kind of voluntold. The curse of being moderately good at doing your summer job. And then during that time, I was working on some invasive plants and some native plants and some newer herbicides. And I was really enjoying it, so I started thinking more about going into a PhD and settled on a PhD program at North Carolina State, also working on aquatic invasive plants. And while that definitely had its ups and downs, I enjoyed most of it. A lot of my research was kayaking on rivers, including getting to kayak up in the mountains. You know, even a bad day in the field, well, with a few exceptions, most bad days in the field beat a good day in the lab. So it was a nice mix of things. And then I had met my predecessor, Dr. John Madsen, at meetings before, and he kind of announced his retirement to this group, this research group that I'm in, and kind of as a long shot applied for his job. Ended up coming out here, interviewing, getting the job, and I started with USDA in February.
Great. And so let's talk about that a little bit. What does your role as research ecologist, what does that entail?
Well, this year is a little bit different since I was having to do a lot of paperwork and onboarding and training.
I'm shocked, I tell you.
Especially in the federal government, there's a lot of training. that you have to do. Luckily, most of it is online now, so it's not requiring to go sit in classrooms and do trainings, which for the most part is really, really helpful. But, towards the end of this year, in the second half of the year and going forward, I'm kind of a good equivalent would be a researcher at a university. So I don't have any teaching and technically can't teach. I can do guest lectures, but it's a full research position. So I'm leading my lab, which right now is just me and my technician. And I get to write research proposals, carry out that research, and direct my technician to do some of the research, write papers, and then present all of that to stakeholders and other scientists. And most of this focuses on aquatic invasive plants because that's my background, and that was kind of the missing niche in our unit. The rest of my unit are entomologists, so they're finding the insects to kill the invasive plants, or one of them is finding insects to kill invasive insects. And then I have one coworker who's a botanist and ecologist as well. And she focuses more on the side of understanding how plants can be so drastically different in different areas and how the environment may affect that. My focus is a little bit more on the figuring out how to kill the plant, mostly using herbicides, but trying to find other methodologies as well.
You mentioned doing presentations to stakeholders, which is kind of how we got on this topic of algae and cyanobacteria, because for those who aren't familiar, we essentially roped poor Jens in when he was very new on the job to come and do a presentation on algae and cyanobacteria in rice. And so with that, I think we're going to get into our topic and start to talk about cyanobacteria and algae, which I'll have to admit, until recently, I wouldn't have categorized them as separate. So can you talk to me a bit about these two organisms and what makes them different and what they are?
Yeah. And I'll preface this with I am no expert on algae or cyanobacteria, but I've listened to some experts, worked with some experts, and luckily, as I'll talk about during this conversation, is there's a lot of overlap between algae and plants and how to get rid of them. So algae are photosynthetic organisms. They mostly live in the water, and they're eukaryotes like you and me and plants and fungi. There are some that aren't just purely photosynthetic, so they're also getting their energy through other means like respiration. But cyanobacteria are kind of, as the name hints at, they're a bacteria, so closer to the things that make you sick, like E. coli or some of our other nasty bacteria. Because they're bacteria, they don't have organelles like mitochondria. They don't have a membrane-bound nucleus. And if you've taken a biology class, you may remember that they have circular DNA as opposed to our kind of helix DNA. But that's going back into the dregs if you ever took a high school or a college biology class.
Yeah, I'm going to have to dig up that memory.
Yeah.
But yeah, that does sound familiar.
Yeah. So there's some functional differences in how they grow. Like also algae reproduce not only from cell division. So when you think about it, if you look under a microscope, or if you've ever seen the video under a microscope of the cell dividing, that's how a lot of algae do it. But they can also do sexual reproduction. So spores, kind of a good analog would be like a fern producing spores. Whereas cyanobacteria, it's only cell division.
I should back up a little bit and say we're talking about this because we often see algae or algal mats in rice fields, especially in rice fields that aren't treated with a preventative chemical to help prevent that buildup. And so when we're talking about algae and cyanobacteria, what are some of the common categories of each that we might see in waterways or in rice fields?
Honestly, most of what has been described to me and what I've read about, I think most of the problems that calling algae in rice are actually cyanobacteria. And this isn't unique to rice. So when you hear about harmful algal blooms like red tide or some of the blooms that are especially really bad in San Diego and LA, those are often also cyanobacteria. So it's kind of like a misnomer because it's easier to say algae than cyanobacteria. It's a lot easier. And the taxonomists really aren't kind to us in terms of giving things easy names. So I think, and from what we know, we thought it was algae at first because they look very similar until you get really, really, really fine into the details. So algae range all the way from little single cell organisms all the way up to like big colonies of multi-cells. And they have a few different categories, the most common being green algae, red and brown algae, diatoms, and dinoflagellates. So a great example of red algae is nori, the algae that you use in sushi wrappers. There's a few other edible ones, but red algae are usually your edible. Brown algae, especially a great example in California, is kelp. So kelp is actually a single cell macroalgae. Macro being like you can see it, and micro is when you have to use a microscope, essentially. The other big category is diatoms. So those have silica. They kind of look like glass and can make really beautiful shapes. But diatoms are often the ones that create taste and odor issues. And another example of diatoms is like diatomaceous earth. So if you have to put that in, sometimes used in potting plants. And then dinoflagellates, they're funny looking little guys that have a flagellum or a little appendage that moves them around. So some of the videos of microscopes, if you see something that's green and has a little tail, it might be a dinoflagellate. And some of the dinoflagellates are the ones that have been most commonly tied to toxins or some of the HABs or harmful algal blooms. For cyanobacteria, the most common examples that I come across in kind of my field and adjacent fields are nostoc, which is what you guys have in rice for the most part. But there's also nostoc that's out by the ocean. So there's the one that kind of looks like a sponge. It's bright green. That grows on the smooth rocks like in tide pools. That's another version of nostoc. And sometimes like the stuff that grows kind of slimy on sidewalks, there's some of those that are another species of nostoc. The other really big problematic one, not as much in California yet, but in the southeast is Lingbia. Lingbia woolii or Microcera woolii. They don't have an easier name for that one yet. It's been a huge problem in the reservoirs in the southeast United States. It's even kind of pushed out some of the historical nasty plants and reservoirs like hydrilla and milfoil. It's such a bad problem.
Can I ask, why has this Limbia become such an issue? Do they have a cause for that?
They don't. They are still trying to understand it. So it's interesting because they think that Lingbia has always been here. It's just never been a problem. And there's a lot of different theories. One of the contributors is probably increased sunlight from, we get better. In some ways, we've gotten better at getting rid of things like hydrilla and some of these plants. So there's more light getting there. The other two are increased nutrients in the water, so having more food, and then more variable temperatures. So the climate is changing, we're getting higher highs, lower lows, and that probably is contributing somewhat to that because you have more warm water, which makes these guys really, really happy. There's been several other theories like decomposing plants kind of serve as more food, but it's not something that they understand really well.
So talking about excess nutrients, that's also something that can feed, for lack of a better word, algae and cyanobacteria. What are these excess nutrients and what quantity, I guess, makes them in excess?
there's not a easy answer to what quantity. It's just more than usual. So in water systems, really, that's more than would be in, say, a natural water body. So for rice, excess nutrients is because you have had to add fertilizer, just like any crops. Or in the natural water bodies that I tend to work in, it's runoff from agriculture, runoff from lawns and gardens, runoff from any other human activity. So we are impacting these areas either on purpose because we're trying to grow crops, or accidentally through some of our other actions. So that just kind of creates that excess. And depending on what else is growing, so in rice, you're trying not to have anything else growing.
Ideally, yeah.
Yes. Sometimes there's more nutrients in there than even the rice can absorb, or in the cases of natural areas, we're talking about more nutrients than the other plants can absorb. So there's free floating nitrogen and phosphorus in the water column, which again are the nutrients that we typically have to add for agriculture.
Absolutely. I know we use a ton of nitrogen in various forms in rice fields, and that's something that is of concern to people. Where is this excess nitrogen going? Because the plants can't uptake it all, and it doesn't last very long. So it makes sense that some organisms, other than the rice, are going to be able to use it. When we have populations of algae and cyanobacteria in fields or even in waterways, what issues can they cause?
Well, I'd say the biggest issue that they're going to cause to rice is inhibiting or hindering your seedling growth. And this can happen through a couple of different ways. It can be as simple as you get one of those scums or films just covering your seedlings, and then they never get to grow. So it'll block the sunlight and either make them stunted, you might not have growth at all, or they're just coated in this slimy algae. The other thing is the algae, it's kind of like a plant. It's creating oxygen. So sometimes what will happen is if that algae is actually in the soil or on the soil surface, it'll create little oxygen bubble. It'll actually be creating oxygen that's going to cause the plants to pop up and dislodge.
Oh, I didn't realize that. Wow. So the force of the oxygen bubbles can dislodge the seedlings from the soil.
That's what I've read, and I don't think that's anywhere near as common as the blanketing issue and decreasing light, but it is something that I've found a couple of papers discussing. The other big issue, and this one's kind of, again, complicated, is creating completely oxygen-deprived conditions. And again, that's a little less of an issue for plants, but still can be. So the algae and the cyanobacteria, again, like plants, they'll create oxygen, but because they might have so much nutrients or so much light, they're reproducing at such a high rate, there's going to be some down where there isn't as much light. And that's when they're starting to use respiration and consuming all of the oxygen. So then they can't keep up, and you get this kind of oxygen-deprived condition, which smells bad and looks bad. If you had anything else trying to live, including like amphibians or something like that, it's going to impact those. And that kind of goes into the next one, which isn't, again, as direct of an issue for the rice producers, but it's toxins. So several of these, and so far, luckily, I haven't seen anything about nostoc, and most of the Lingdia doesn't produce this, but, if you've heard about harmful algal blooms or red tide, you know that sometimes there are these conditions. So luckily not in rice, but there are issues where some of these algae blooms can produce toxins. And sadly, at least once a year, you'll hear a story where, a dog dies or a kid gets really sick. My cousin, his dog went swimming, and it wasn't a rice field, but it was a pond. And before he could stop her, she went in the pond, went swimming, and they had to take a trip to the vet ER. She's okay now. Good, happy end of the story.
Phew, I was afraid I was going to have to put a warning there or something.
No. She just got sick and wasn't happy for about a week, and she pulled through. But you do hear those sad stories about where the dog doesn't pull through. So if a grower is allowing people to hunt in their fields or adjacent to their fields, I mean, this could even be the outflow if they're draining after a flood event or a high rain. So it's the surrounding area you have to think about too. And you don't want to get tangled into somebody being, trying to blame you for that. And then again, the kind of last really big one, but not as big in rice, is taste and odor. And this is a really big problem for our drinking water reservoirs, of which we definitely have a few here in California and is all over the Southeast. So some of these, especially those diatoms, can be linked to taste and odor issues. And then they have to spend a lot of money treating the water extra because nobody wants to drink smelly water.
I know I don't. So you mentioned treatment. So how do we get rid of algae and cyanobacteria in reservoirs, waterways, and then rice fields?
The first one, as anyone that's ever worked with a invasive or weed, is prevention. So it's trying to stop it from getting there. And as I touched on when I was talking about Bolivia, algae is in your water because it's a natural part of a healthy ecosystem. So if you're getting water from a drinking water reservoir or pulling it from a river, there's going to be algae there. But again, that stagnant, high light exposure water that you're trying to grow rice in is also the perfect habitat for this. So through what I've read, the number one way to try to prevent it is actually incorporating your fertilizer before the last tillage. And actually, somebody in my unit and Bruce Lindquist did some of that research where they were trying different ways of preventing the algae. They incorporated it, or they suggested waiting. They did some studies where they waited as long as possible to actually add the fertilizer and wait until rice is above the water surface. So then you don't have that algae. Now that could potentially affect yield. So that's kind of a give or take. So their kind of better suggestion was the incorporation. But the other suggestion that I saw they made was if you're doing top dressing of nitrogen later in the year, you could do nitrogen and phosphorus at the same time. So you're not having to go back and do it repeatedly and keep the costs a little bit lower. But again, you have to, there's probably a learning process because you're going to have to figure out how any of this may impact your yield or the cost of actually doing that incorporation. So obviously preventing is one of those things that's great in theory, but it doesn't always work, sadly. One other prevention that I saw that was kind of a long shot that they were suggesting in Arkansas was using some sort of water movement. So doing multi-inlet irrigation or even having some sort of pump in your field for the initial period where you're actually moving the water around to get that agitation, and that might help reduce the amount of algae. But again, you're going to have to put a pump in there, so that's not always a cost-effective measure.
Yeah, and I'm thinking, at least in our fields, a lot of our fields are broadcast by airplanes, and
yes.
There might be a bit of seedling drift if we were to do that. Maybe more of a drilled rice strategy.
Yeah, that would definitely have to be in drilled rice, and I think that's where they were testing that one. The other big prevention is not using, this isn't common here, but not using aquatic vegetation, so like aquatic plants or algae or cyanobacteria as compost, because that's done especially in the global south, in Southeast Asia and other parts of in India, where they're having fewer of these problems. So they have much more nitrogen and phosphorus poor soil in some areas. So they actually use the algae as compost. And that would not be a smart thing for areas like here where we're having issues with the algae. I think the last minor one that I forgot about was trying not to use urea because it's kind of the perfect food for the algae. So kind of circling back into post-prevention. Well, in California, the only legally labeled thing is copper sulfate. And I know there's been a few students trying other things. Basically, what one of former UC Davis student found was the sooner you apply copper sulfate after planting, the better it is. But there is that kind of, you do have to tailor that because you definitely also don't want to burn the plant. So I think they found, within 7 to 14 days is kind of the safer range in terms of actually controlling the algae. There was also a little bit of work looking at using the liquid formulations of copper sulfate rather than the pelleted forms, and they saw a little bit of efficacy increase there, so it worked just a little bit better. And, when you have a big algae problem, a little bit better probably is going to help out. Going into the kind of future options that somebody should be looking into. In natural areas, we use a few other herbicides. And actually, my master's advisor did a little bit of work looking at some of the ALS inhibitors to see if they would work on algae. And he found that panoxylum and bispirabac, both of which are registered in rice, did control some algae species. So that's not a universal thing, and obviously it's not labeled, so you can't go out and do it. But it's something that could be looked into, since they are already registered products that could have some potential use.
I was going to say, they've already got the hard work of getting a chemical registered in California rice done with. So that might be a really interesting project to look into. But once again, not currently labeled.
Yes. Yeah. And again, making that as clear as possible. But if they're used, you could start off as simple as, if somebody's using those, look at, are you getting as bad algae if you're using those herbicides? And again, it didn't work on all of the algae and cyanobacteria, is just some of them. But in natural areas, we also use things like endothol dimethylamine, so hydrothol 191 or Teton. I'm not sure if those are the names registered that other folks would be familiar with. We also have tried things like peroxides and copper ethanolamine complexes or chelated coppers. But again, those aren't registered in rice. And then there's some work looking into things like yeast protein activators. Those again are things, some of those are registered in California and could be an avenue to look into, but I'd say there's kind of a tiered list of things that are worth looking into. And I do think that one of my predecessors, Dr. Dave Spencer, did look at the dimethylamine on nostoc specifically in California, and it didn't work. So that one might be a non-starter. He kind of staying on that stint, he also did some work looking at barley straw, because that one pops up every once in a while. And it worked pretty well in the United Kingdom. But again, and this one again kind of falls into that it's not registered for use, because you're saying it's a treatment, so it should be registered. And people have tried to do it, but in terms of actual use, barley straw isn't a registered thing to do in algae management. And what they found out in California is that it really didn't work for algae control. And I know that I was reading a paper the other day in Arkansas, or it was actually a student's master's thesis, where they tried it again in Arkansas, not only with barley, but with rice. And again, it just really wasn't working. So, just based on what I've read, I wouldn't go too far into trying it, even as kind of a last ditch. It just doesn't seem like it's doing as much with the algae and cyanobacteria that we have here in California.
Now, I'm glad you mentioned that. We've heard a bit lately from some growers who are interested in seeing the barley straw research come back because they've heard stories, oh, so-and-so did it and it worked and things like that. But I've read similar, I guess, papers where they have tried it and it's not yet, I don't want to speak out of turn, but I haven't seen any success rates in United States rice production.
No, and I think I haven't seen anything in the U.S. either. I think it was one of those things that worked really well in the United Kingdom in like a couple of ponds. And it may be continuing to work there. Haven't seen anything more recently out of there, but unfortunately, it doesn't seem like it's one that's gonna work well, especially in California.
Well, Jens, I know this isn't really a fair question to ask you, but I'm going to ask it anyway. Do you know of any upcoming research by any member of your team or any colleagues looking at treating algae and cyanobacteria?
Not in rice. I know. So some of these problems are similar to some of the ones we're having in natural areas and lakes and rivers. And in fact, I was in some conferences recently where people were talking about, the management steps. So I know folks like the Army Corps of Engineers are looking into more of a broad harmful algae management, but I don't know of anyone specifically doing the rice ones. I have started trying to send out some feelers to see if they know of anyone, because when I talked to them about it, they were like, oh, I remember this coming up when I was, where I was and stuff like that. So it's kind of funny that a lot of our problems with weeds and with algae and all that are kind of a circle. It's if you go back, it's like, oh, this was here then, and then it disappeared, and now it came back, kind of deal.
Same old story.
Yep.
Well, then, as an aquatic weeds, a specialist in aquatic weeds, I'm going to ask you, are there any aquatic issues we should be on the lookout for in California? And this doesn't have to necessarily be rice.
Yeah. I'd say one of the ones that I know is algae is the Lingbia, because they're seeing more of it in Southern California, and there are a few hits. There's some folks doing GIS and mapping of it, and there are a few hits in Central California and in the Sacramento, San Joaquin River Delta. And since it's exploded across the Southeast, it's definitely one that you should keep an eye out for. It kind of just looks like a floating, bubbly, matted algae. And it smells really, really, really bad. If you smell something that's really bad and you've not smelled it before, and there's algae in your water, there's a chance it's Lingbia. But the other ones that I think are to be on the lookout for are some that are kind of existing issues, like the pond weeds, because they reproduce, asexually and sexually, so they can have seeds that'll, transfer in your water sources or stay in your fields. Another one that's kind of a concern is yellow floating heart. It's Nymphoides peltata. It's this really pretty float plant that forms these little lily pad looking leaves, and it's a huge problem in Oregon and Washington. It's kind of on the radar for the Delta and Northern California. Another one that I actually am working with Whitney on and a few other folks is the winged water primrose, or Lowigia decurrens. So we actually have some planned collaborations because it sounds like that's kind of becoming a recurring. It's, how we're talking about things are a circle. It sounds like it wasn't a problem and now it's coming back. And my bigger concern is if you look at a map, a lot of these are connected to the delta. And if it gets into the delta, then we have another weed, and the weed managers in the delta are already overworked as is. So I'll actually be doing some work looking at some of the aquatic registered herbicides, because we don't have the same access to herbicides that rice does. And this can even include things like irrigation ditches or irrigation canals. So it's kind of, right now it's preventative in terms of it reaching the delta, but it sounds like it's a growing concern even among rice growers. And then I guess the final one, that's another plant that's near and dear to my heart, is Australian eelgrass, or Vallisneria. It's a growing problem in the delta, and it is one that I've talked to a few people that they see concern of it moving, kind of backwards into irrigation, because it's can spread so aggressively, and it's in a lot of popular fishing spots. So, and it has moved upwards against the flow of the delta. So it's not just going downstream. So that would be another one to look out for. But I would say the top two that I would keep my eye out on are any sort of new pondweed and winged water primrose.
That is great information, Jens. I'm glad you mentioned that about the Ludwigia, because we saw more of it than we were expecting to this season. And I think for a lot of us, we were having some trouble because there is another Ludwigia that we've been seeing. It's not the discurrens, but it's a very similar looking plant. It's just got a different number of petals, and it's got a slimmer stem. I guess I'd say it doesn't have the wings coming off of the stem. And so for us, I think a big part of our extension work concerning that weed this year was just kind of identifying the differences between them. Because the first one's pretty widespread, at least in our waterways. And yeah, it's invasive. It's pretty good at doing what it does, but it's not nearly as big of a problem as the discurrens is. And that's something, I'll be honest, we're a little bit frightened of.
I think frightened is the right, not to be doom and gloom, but frightened's a good mindset, because you don't want to be complacent about it, right? I think complacency in new weeds or old weeds getting bigger, it can be a problem. So I think being frightened is the better mindset to have, rather than letting it sit.
Glad to hear that. So now, Jens, can people contact you or reach out to you to get more information about aquatic weed management?
Yes, they can. I do have it's not optimized yet, because that's a slow process, but I do have a website on the USDA webpage. If you Google my name and USDA, it'll pop up, or you Google the USDA Invasive Species and Pollinator Health Research Unit, my name's on there, and my contact info is also on there.
And we'll have a link to that in the show notes for anybody who's interested in that. And just for, I know how to spell your name because I'm looking at you, but let's spell your name out, because it might not be what some people are used to.
Yeah, so it's Jens, and then my last name's like the vegetable, Beets. So actually, if you're looking to just email me off the bat, my email's pretty simple. It's my first name, period, my last name, at USDA.gov.
That's a nice email address. You got lucky there.
I know. They like to keep them simple in the government. They only try to go to middle initials if they really have to. And, I'm happy to answer questions people have, but more likely I'll try to connect you with the people that are a little bit more expert on this than I am. Although the weed questions I have, it's the algae questions that I'll be farming out answers as much as I can.
That's the best way to use our resources, right? Is to actually use them.
Yep.
Now with that, Jens, before we go, is there any upcoming events you'd like to promote?
Actually, there is. So one of the societies that I've been in since I started grad school, the Aquatic Plant Management Society has their regional chapter meeting in Sacramento this year, March 17th to the 19th in Sacramento. It's a smaller meeting, but it's usually pretty good, and they cover all sorts of issues from across the Western United States. And every once in a while, there'll be students from other parts of the country coming to give talks. And it's a nice mix of student talks and managers and applicators. I know there's a really commonly talking about flowering rush, which is another big problem in the Pacific Northwest. Luckily, I'm not putting that on my list of things to be concerned about in California yet, but hopefully it stays that way. But it's a fun event, and if anyone can make it, I would strongly suggest it.
Any other information, links, or resources you want to share with our listeners?
Yeah, so I'll also give a little plug for another podcast that I really enjoy. It's out of University of Florida. One of the co-hosts is somebody that I worked pretty closely with when I was there, Dr. Jason Farrell, who is the center director out there. And now I think he's the dean of agronomy, or some higher up position. I can't remember his exact position, but he knows what he's talking about. They also are really good at bringing, subject matter experts. I don't think they have an episode on algae specifically, but they do a lot of things about, they did a couple of episodes on talking about silent spraying and how that reshaped herbicides and shaped what we do with herbicides today in, crops and non-crop systems. And they talk a lot about, the different lakes and rivers that they have to work on and new weeds that are popping up. So I think it's a great one. And I think they do a really good job of making it interesting for all audiences. You don't have to know a lot about these things. They have a couple of fun trivia episodes with grad students. So I'll give that another plug as well.
That sounds awesome. We'll definitely have a link to that in our show notes, and it'll also be on our pod roll of suggested podcasts that if you like our podcast, you'll probably like this one. With that, Jens, thank you so much for coming on today. I know rice isn't necessarily your first area of comfort, but I really appreciate you taking the time to do this.
Yeah, of course. Thanks for having me. I think we've got some work planned with your group that may make me a little bit more comfortable with rice in the first place. So I'm looking forward to it.
Well, then I'm going to keep you in mind because I like the sound of those kayaking trips. So we'll have to go and see some aquatic weed management.
Yep. There we go.
We have announced the dates for the 2025 Winter Rice Grower Meetings. And so we're going to continue the same format we've had in previous years, having a series of repeating meetings across the rice growing region. So it's okay. In fact, it's suggested don't go to all of them. You'll be pretty bored, but try to make at least one of them. The same information will be presented at all of them. And so I'm going to read off this list of dates, but please keep in mind these dates are on our blogs, on our websites, and our newsletters, so anywhere you need to get more information, go ahead and look for that. Without further ado, here are the dates and area locations for the 2025 Rice Winter Grower Meetings. The specific locations are currently TBD, but here's just the general town they'll be in so you can kind of plan your early spring. February 10th in the morning will be the Woodland meeting. February 12th in the morning will be the Richvale meeting. February 12th in the afternoon will be the Willows meeting. February 13th in the morning will be the Colusa meeting. And finally, February 13th in the afternoon will be the Yuba City meeting. Again, those specific locations are TBD. They will be in those towns, but we will have more information later on, and we will be sure to get that out to all of you as soon as we have that accessible. To learn more about the UCCE Rice program, please feel free to look at our resources, which include the UC Rice blog, the UC Agronomy Rice website, and our newsletters, which are Rice Briefs, which covers Colusa and Yolo, Rice Notes, which covers Yuba Sutter, Rice Leaf, which covers Butte and Glen, and Field Notes, which covers rice in the Delta region. Thanks for listening to Thoughts on Rice, a University of California Cooperative Extension podcast from the University of California Agriculture and Natural Resources. You can find out more about this podcast on our website, thoughtsonrice.buzzsprout.com. We'd love to hear from you, whether it's from using our text link in the show notes, a survey submission in our feedback form, also in the show notes, or in a comment or rating on your podcast streaming service of choice. You can comment or rate on any service. We will get it, and we would be interested in it. You can also email us with any comments, questions, or concerns at thoughtsonrice@ucdavis.edu. Hopefully everybody gets to breathe a little bit now that harvest is done. And remember, like the growers like to say, have a rice life. Mention of an agrochemical does not constitute a recommendation, merely the sharing of research findings. Always follow the label. The label is the law. Find out more at ipm.ucanr.edu. The views, thoughts, and opinions expressed are the speaker's own, and do not represent the views, thoughts, and opinions of the University of California. The material and information presented here is for general purposes only. The University of California name and all forms and abbreviations are the property of its owner, and its use does not imply endorsement of or opposition to any specific organization, product, or service.